Hello, I am George Rodriguez, a business manager specializing in the agribusiness market across Latin America. Today I want to bring to your attention a topic that is of strategic importance and one that, in my view, is still underestimated by a large part of the input supply chain. Struvite as a domestic alternative to imported phosphate fertilizers. Embrapa Agrobiologia has just published research with highly relevant findings. I am going to break this down for you here from an agronomic, formulation, and market perspective. The news. Scientists at Embrapa Agrobiologia, based in Rio de Janeiro, have demonstrated that Struvite, a slow-release fertilizer produced from swine production waste, is capable of supplying up to 50% of phosphorus demand in soybean crops, whilst maintaining productivity equivalent to that achieved with conventional fertilization. The field experiments recorded 3,500 kilograms per hectare using Struvite. For context, the national soybean average in 2025 was 3,560 kilograms HA under conventional fertilization. That is a difference of less than 2%. And the figure that puts everything into perspective, Brazil currently imports approximately 75% of the phosphate fertilizers it consumes. 75%. That is strategic vulnerability. That is supply chain risk. That is what keeps us dependent on international price fluctuations and the geopolitical decisions of a handful of producing nations. What is Struvite? Technical overview. For those who are not familiar with the product, let me be direct. Struvite has the chemical formula we have, magnesium ammonium phosphate hexahydrate. It contains approximately 12% phosphorus, 5% nitrogen, and 10% magnesium. Its principal agronomic characteristic is low solubility. Phosphorus is not released immediately into the soil. It becomes available gradually throughout the crop cycle. This is precisely what makes it noteworthy in the context of tropical soils. Consider this. Brazilian soils, predominantly latosols, oxisols, are acidic, rich in iron and aluminium oxides, and have a very high phosphorus adsorption capacity. What does this mean in practice? That a significant proportion of the soluble phosphorus we apply today is immobilized rapidly before it can be taken up by the plant. This is one of the greatest agronomic efficiency challenges we face, and this is where Struvite makes its case. Because its release is slow, it reduces the exposure window of the nutrients to adsorption sites in the soil. Its alkaline reaction in the soil, in contrast to the acidic nature of soluble fertilizers, also contributes positively in low pH environments. The outcome: a greater fraction of the applied phosphorus effectively reaches the plant root. The researchers also developed an organomineral formulation combining Struvite with organic matter, and in phosphorus diffusion tests in soil, this formulation delivered results 50% superior in the first 28 days compared with pure granulated Struvite. This is highly significant from a formulation development perspective. Strategic importance for agribusiness. Why does this matter for Brazilian agribusiness? Let me put it into perspective. Phosphorus is the second most important macronutrient for crops, second only to nitrogen. It is essential for root development, flowering, grain filling, and maturation. Without available phosphorus, productivity falls. It is as straightforward as that. And unlike nitrogen, which is abundant in the atmosphere and can be biologically fixed, phosphorus comes from phosphate rock, a finite, non-renewable resource. Global reserves are concentrated in a small number of countries: Morocco, China, Egypt, and Algeria. Brazil, with its limited domestic reserves, is in a position of high structural dependency. Brazil's national fertilizer plan already acknowledges this. The goal is to reduce external dependency, and Struvite is fully aligned with these policy directives as a domestic, sustainable, and highly efficient technology. Furthermore, Brazil is one of the world's largest pork producers. The southern and center-west regions host intensive animal protein production, generating effluents rich in nitrogen and phosphorus that currently represent an environmental liability. Converting this liability into a high-value agricultural input is, in concrete terms, the circular economy applied to the livestock and crop production chain. Embrapa estimates that adoption of the technology on farms with more than 5,000 pigs could generate approximately 340,000 tons of struvite per year across the country. Pros and cons, technical and commercial analysis. Now let me be candid about both sides of this equation. On the side of the pros, first, differentiated agronomic efficiency in tropical soils. The slow release mechanism and alkaline reaction place Struvite in an advantageous position relative to MAP and SSP under high adsorption conditions. Second, the potential for incorporation into organomineral formulations. Embrapa's preliminary results are very promising for those working in formulation development. There is clear scope for second-generation products with high performance characteristics. Third, measurable environmental benefit. Reduction of soluble phosphorus in water bodies, decreased risk of eutrophication, and the viability of expanding livestock operations that are currently constrained by soil nutrient loading limits. Fourth, a new revenue stream for the swine producer. The farmer becomes a supplier of an agricultural input. This is genuine value creation at the base of the supply chain. On the side of the cons, and this is essential, first, the absence of regulatory registration. Struvite does not yet hold registration as a fertilizer in Brazil. This means it cannot be marketed at commercial scale at present. The research is still in the scientific validation phase, and the path to full registration is lengthy and requires further evidential support. Second, commercial production scale has not yet been demonstrated. Producing Struvite in laboratory settings or on pilot farms is vastly different from establishing a supply chain with the volume and consistency required to meet agricultural market demands. Third, performance variability across soil crop systems. The published experiments focus on soybean and wheat. There are significant gaps in knowledge regarding the product's behavior in other high-relevance crops: maize, sugarcane, cotton, and coffee. Each crop has a distinct phosphorus uptake dynamic. Fourth, decentralized logistics and processing. Struvite precipitation occurs on pig farms which are geographically dispersed. Establishing an efficient logistics chain to consolidate, process, granulate, and distribute this material represents a genuine operational challenge. Market outlook and opportunity. For those operating in the agricultural inputs market, whether in industry, distribution, or portfolio development, what I see here are two simultaneous strategic movements. The first is active monitoring, tracking the progress of regulatory registration, the field results from ongoing research, and the advancement of regulation by MAPA, Brazil's Ministry of Agriculture. When the product reaches the market with full registration, those who already understand the technology will have a decisive head start. The second is formulation development. Incorporating Struvite into organomineral formulations combined with soluble phosphorus sources has the potential to be a compelling value proposition. Products that balance slow release with immediate availability are precisely what high-performance producers are seeking. Closing. Embrapa's research on Struvite is not merely another academic publication. It points towards a possible structural shift in Brazil's fertilizer matrix, less external dependency, greater agronomic efficiency, improved sustainability, and more value generated within the domestic agri-food chain itself. This is food sovereignty in practice. This is innovation with purpose. If you would like to take this conversation further, please leave a comment or send me a message. I am following this technology closely and I believe it will be part of Brazil's precision nutrition input portfolio in the years ahead. I am George Rodriguez. Until the next piece of content,